So this is the beginning of the extreme value theorem and how to find absolute extrema. So we will be looking for the absolutely highest point and absolutely lowest point. So we are switching from relative extrema to absolute. So relative, there could be several on a graph. We could have lots of regions that have a high point, but absolute is talking about the highest point. So we are switching from where do they take place, which would be at x values, to what are they, which would be y values. So the extreme value theorem is an existence theorem, much like the mean value theorem that I'll go into more in the next slide. But I wanted to take a look at these graphs to kind of help you understand what's going on with the extreme value theorem. So I have the same graph, sort of. I've put discontinuities in different places. So I am looking for the absolutely highest point, which on this first graph is a y value of 5, and the absolutely lowest point, which is a y value of 1. Now notice I'm giving y values, not x values. Also notice that one of them took place at an endpoint, which cannot happen with relative, and one took place at a critical number. The graph flattened out there. All right, so look at the second graph. I still have an absolute maximum of 5, but there is no absolute minimum. It doesn't matter how close I get to that open circle, there's always a point closer. So I say if I get this far and then I zoom in, that point might be actually here, and it could keep happening. So I'll never get to a lowest point. So there is no absolute minimum because I have a discontinuity, a removable discontinuity where it would take place. So if you look at that graph and you might think, well, if the graph's not continuous, you might not be guaranteed an absolute max or min, and that is one of the things that the extreme value theorem actually states. All right, so look at the third graph. I filled back in the hole, so I do have an absolute minimum of 1 again, but I don't have an absolute maximum because I put a hole on the end point. So there is no max on this graph. So one of the other things that the extreme value theorem says is that it has to be continuous on a closed interval. So the only one where that actually takes place is this first graph. It's continuous on a closed interval. I'm starting from a point, ending at an actual point, and I don't pick up my pencil along the way. So those are the conditions, two of the conditions for that theorem to happen. So it's an existence theorem, and it talks about the existence of both a max and a min if it's continuous on a closed interval.